Welcome back. In previous lecture, we talked about the criteria for hydraulic system and components selection. What need to be considered while designing and selecting hydraulic system components and parts. In this lecture, number 11, we'll discuss the common two types of a typical hydraulic system, which are open and closed loop systems. We will also understand the basic function of each system and what are the advantages and disadvantages of each circuit. So let's start. Open loop and the closed loop systems are two types of hydraulic system. In general, if the fluid flow from the actuator, normally a cylinder, first goes to a reservoir and then fresh fluid or oil from the reservoir flow to the pump inlet, then this system is called an open loop system. I have here an oil tank, pump, and actuator. If the oil is moved from the pump to actuator back to the oil tank, then to pump actuator back to the oil tank, this is an open loop system. On the other hand, when the hydraulic fluids flow continuously between the pump and actuator only without going to the reservoir, then the system is called closed loop systems. Like this picture. I have here a pump and here the actuator. The oil will move or flow between only these two items without going back to the oil tank or reservoir. This is a closed loop circuit. So in brief, oil is pumped constantly and excess oil returned to the reservoir is an open center system. The oil or fluid will flow between pump, actuator, and tank. However, for the closed center systems, the oil will be pumped on demand and the fluid will flow continuously between the pump and actuator without entering to reservoir. In open loop system, when the actuating mechanism is idle, that means I have no motion in the actuators, it is just stopping, there will be fluid flow but no pressure. So these circuits where both inlet to the hydraulic pump and motor valve returns are connected to a hydraulic reservoir. The fluid flow from the pressure port on the pump is directed to the device that's empowering and then returned back to the reservoir. A relief valve or a directional valve in the circuit may divert unused fluid back to the reservoir. The main advantages for open loop circuits, they are generally less expensive compared to closed loop system, better for low pressure applications below 3000 psi, and simple to maintain and easier to identify or diagnose problems if they occur. The disadvantage for open loop circuits could create heat in the system if working pressure exceeds the relief valve settings when using a fixed displacement pump. If the pump used in the system, the pump used in the hydraulic system of a fixed displacement type, then there is a chance of a heat generation if the pressure exceeds the relief valve settings. Also, the second disadvantage is reservoir size has to be very big or large for adequate cooling of the fluid. If we go for the closed loop circuits, these circuits where the motor return is connected directly to the hydraulic pump inlet. To maintain the pressure in the loop, the circuits have a charge pump, small gear pump, like here. This is an additional pump that supplied cooled and filtered oil to low pressure side. Closed loop circuits are generally used for hydrostatic transmission in mobile applications. The reservoir only has to have enough capacity to feed this small pump. These circuits are mainly used with high pressure piston hydraulic pumps and motor. Hydraulic pump will deliver in this system the fluid to actuators and will receive the same quantity of the fluid from its inlet port from the actuator for smooth operation of the system. The volume is constant here. Just imagine the pumped fluid will be going back again to the inlet of the pump. However, Again, one feed pump is always provided with a closed loop hydraulic system in order to make up the fluid in closed loop circuits. And feed pump will have fixed displacement of a capacity approximately 15% of the main pump. Also, in case of closed loop hydraulic system, main hydraulic pump can deliver high pressure fluid from its both ports, and therefore the main pump will control the direction of rotation of any hydraulic motor or actuator. Not like other in open system, we have a directional control valve. Here the pump itself can rotate in both directions, and hence you can have both direction rotation of the actuator or motor. For closed loop system, the main pump can control the direction of rotation of any hydraulic motor. The main pump also can control the pressure and the flow of the fluid in closed loop hydraulic system. And that's why controlling elements such as a directional control, flow, and pressure regulating elements will not be required for closed hydraulic system. If we start with the advantages of closed loop system, the system can run at higher pressure with less fluid flow, so small hydraulic lines can be used. Direction can be reversed without the use of valves, like in case of the open circuits. More control options also are available in closed loop circuits. And here, closed loop hydraulic system is suitable for precise working, but the problem of heat generation in this case will be higher as compared to the open loop system. The disadvantage of closed loop circuits are more expensive, components will be used, require high pressure filtration, sometimes because the oil is not going to the tank, the oil is pumped between the pump and the actuator, so it may require high pressure filtration, and more difficult to diagnose any problem or repair it if it is occurred. This is just a comparison between the open and the closed loop hydraulic systems. If you see here, for the open loop hydraulic system, in case of neutral, there is no movement of the piston. If you can see, the oil is pumped here continuously, going back to the tank, moving continuously, going back to the tank. During operation, I have the valve is shifted here, and the oil will be moving, going to the piston, lifting up, and the remaining will be going back to the tank. In case of closed loop system, this is neutral position, the piston is not working, then the fluid here is maintained, okay, and during operation the pump will give the fluid to lift the piston back up, and the continuous operation between the piston and the pump. Thank you, and see you in next lecture.